Hello and welcome. My name is Keith Barker. And have you ever had a time when the internet went down or it wasn't available and you're like, oh no, what do I do? Well, for me, that's a huge problem as well. And so what I did over the last couple months is I set up some fault tolerance, some nonstop internet, so that if one service provider fails, the other one can keep on providing service to my home and to my office without any interruption. In this video, I'd like to walk you through the pieces and parts that I used to accomplish exactly that. So for our discussion, let's start off with a big cloud representing the internet. Let's imagine this is our home office that we want to have connectivity to the internet from, and the company that's providing that internet service is often referred to as an ISP, which is an acronym for Internet Service Provider. So up to about a month ago, I had a single internet service provider, which was providing connectivity to the internet for my home. And that was a cable company, coaxial cable. And currently in my area, I'm in Nevada, I'm using Cox Communications. And I've had great service with Cox Cable for decades. However, what happens in the event that there is a failure or a problem with the Cox Communications and their cable services? Basically, everything in my house that's relying on internet services is going to fail. So there's a cable that actually goes into my house, and there's a little box called a cable modem. And think of a cable modem like a translator that speaks two languages. It speaks the language on the coax cable, this is RG6, with the signals coming in from the service provider, and it also speaks Ethernet. And Ethernet is the common technology we use for high-speed local area networks, for example, in our homes. And so this could be wired, or more likely we have a little access point doing wireless service in our home as well for our wireless devices. And I have had great success and great service with Cox Communications, and I'm not being sponsored by them, but I've had great service for more than 20 years, and I love it. However, what if there's a hiccup or a problem or an issue with their cable service at any point? And this goes for any cable provider. If this is the sole provider of internet service to this home, and that fails, everything that's relying on internet service here in the home through that service is going to be disappointed as they try to go out to the internet if there's a problem from that service provider. So how in the world do we get high availability and fault tolerance and tolerate a failure or a fault from a single service provider? And the answer is, when we're talking about high availability and fault tolerance, which is the ability to have a single fault in the network and keep on going, the solution to most of that is two or more devices. And let me explain what I mean. In a corporate environment, when we have routers, this is router 1 and router 2, and let's imagine this is the network they're supporting, and so we have users and other devices that are on this network, and they're using a default gateway. And they learned about that default gateway through a protocol called DHCP, Dynamic Host Configuration Protocol. And let's imagine that they are learning to use the address of .5 as their default gateway to get off of this local network. So for fault tolerance, if we have two routers that are providing that routing function, we can have them work as a team with some software that's having them keep track of each other. So that way, if router 1 is doing the forwarding for all the traffic off of this local network, and router 1 has a problem, R2, because it's using keep alives and heartbeats and keeping track of the other device, if it notices that R1 is gone, it can pick up the slack and currently forward all the traffic and be responsible for that .5 default gateway address. The goal is to be transparent to the users so they don't even know there's a problem. They're just forwarding traffic, they're happy, and life goes on. So that's an example of tolerating a fault in our network by having two routers and some software running between them that can track each other and then take over in the event the other one fails. And some of the protocols that are used between two routers to provide that fault tolerance are VRRP, which is the Virtual Router Redundancy Protocol, which is an open standard. Cisco's got one called HSRP, which is the Hot Standby Router Protocol, and they've also got another one called GLBP, which is the Gateway Load Balancing Protocol. But at the end of the day, it's the software and the technology that's used between two routers so that if one fails, the other one can take over and it can be transparent to the users. We have a similar concept like that with firewalls. So if we have two firewalls, Firewall 1 and Firewall 2, which are supporting a network. So here's our network, here's our little devices connected to the network. We could have these firewalls acting as a team. So once again, it takes two firewalls and then some software. In this environment, we'd call that HA, high availability, where they're watching and paying attention to each other. So if one of them fails, the other one can immediately take over and have no disruption of service to the customers that are going through that set of firewalls. And one last example here of high availability, we may have some servers that are all working as a team. And then in front of those servers, we place a device called a load balancer. And various companies have different names for this load balancing function. And with this in place, when the user goes to a server, instead of really going to that server directly, they're going to the load balancer. And the load balancer is keeping track of which servers are up and which servers are least busy. And then the load balancer can direct that traffic to the appropriate server based on that server being up and available. So this is yet another example of implementing high availability and some fault tolerance by using a load balancer in front of a group of servers. So the question may be, well, Keith, that's fine and good about, fault tolerance and high availability, but how is that going to give you nonstop internet at your home? I'm glad you asked, because here's exactly what I did. I realized that I need 2 different providers in the event one of them fails. So this is provider number 1. And then I have a second service provider, which we'll call service provider number 2. And in my home environment, I'm currently using T-Mobile, which I just got last month. And I'm using their home internet solution, which runs on 4G and 5G. It's also important to note that I'm not being sponsored by T-Mobile. That was the best option I have at this moment with where I'm located. Now, as part of the T-Mobile solution, I took their little home Wi-Fi or home internet canister and I modified it a little bit to put external antennas on it. And to put the external antennas on, I actually watched a couple great videos on YouTube that walked me through the disassembly and the connection to external antenna. And the antennas I used are actually on my roof. So I got a couple directional antennas. I've got some LMR 400 cable, which is shielded going from the antennas on the roof down to this device. And then this has Wi-Fi options. It also has a cabled option with Ethernet. So I disabled the high-speed local area network Wi-Fi services on this T-Mobile internet device, which is actually made by Nokia. Because I'm not using the Wi-Fi services there, I just wanted the alternate path via Ethernet that goes out to the internet. So let me clean up my workspace here a little bit, and let's continue the story. So now I've got 2 internet service providers, and I've got the connectivity at my home, but now how do we use those effectively and make it transparent to everybody in the house? Which also includes everything in my studio here that I'm using to record. And the device that I'm using to coordinate and monitor both these connections is a firewall. It's a next generation firewall, and this one is from Fortinet, and their next generation firewall is called FortiGate. So I've got these service provider connections coming in. One's coming in on a physical interface called WAN 1 on this FortiGate firewall, and the other provider's connection is coming in on an interface called WAN 2. And those are 2 Ethernet ports on this FortiGate firewall. Now, the tricky part about using these links and these service provider connections effectively, making it transparent to the people in the home. So I'm going to go ahead and draw the inside connection as being here, representing these are the devices in my home and in my office that are using the internet. All my home sees is a default gateway right here at the firewall. And that includes wireless clients and wired clients. They all see the FortiGate firewall as their default gateway to get off of the local networks. And so as their traffic goes up to the FortiGate, it can then be sent out WAN 2 or WAN 1. And that's the next trick is, okay, how do we know exactly if these links are good, meaning we have good throughput on both of them, and how do we choose which one is going to be used? And FortiGate has one of the most elegant solutions and easy to implement solutions that I have ever seen regarding making that work. And the method they're using to implement this is referred to as an SD-WAN zone. And SD-WAN stands for Software Defined Wide Area Networking, and there's some intelligence built into this functionality. Let's talk about it here for a moment. What I did was I created a new SD-WAN zone, and I said, hey, WAN interface number 1 and WAN interface number 2 are in that zone. And then I included that as part of my firewall policies and my routing. So the firewall has now the choice of using, when it's forwarding traffic out to the internet, WAN interface 1 through the provider number 1 or WAN interface 2 through provider 2. And so in addition to creating this zone and specifying that these 2 interfaces were members of this zone, I also set up some health checks. And when using this SD-WAN zone feature, these health checks are known as SLAs, which is an acronym for Service Level Agreements. Think of an SLA as checking to see whether or not you're getting what you paid for at that link. And in fact, I want the firewall to be able to check periodically and see, hey, what is the measurements on WAN 1 and WAN 2? Because if WAN 2 goes belly up, I don't want to try using it. Or if WAN 1 has a problem or is really slow, I want to take that out of commission for a little bit, just use WAN 2 and have that be transparent to everybody in the house. So the measuring of those links are known as health checks or SLAs to do the measurements. And one last big piece of this is that based on those health checks and these interfaces that are part of the SD-WAN zone, we can also set up SD-WAN rules, which are going to specify to the firewall when it should be using WAN 1 interface and when it should be using WAN 2. And we can base those rules based on the health checks. So we could say, for example, let's use WAN 1 all the time. And if there's a problem with the internet connectivity through WAN 1, based on the health checks, let's cut over and use WAN 2. And again, that'd be all transparent to the users who are in the home or in the business using the internet service. It'd make that transparent cutover in the background. Or we could say, let's do load balancing across both of these interfaces if they're both meeting the health checks. And we can also set up a ratio. We could say, I want to go ahead and use 3 times the quantity of traffic here and compared to 1 over here if this link is 3 times faster and so forth. And there's all types of rules that we can set up regarding which interfaces we're going to use and when. Now, I discovered through my testing that if we do load balancing, where a user is sending out traffic and is sending some of the traffic out WAN 1 and some of the traffic out WAN 2, there are some applications and services that absolutely do not like that. In fact, in my testing, one of my services said, hey, you're trying to log in from 2 different places. And that's because some of my traffic was going out WAN 1 and some was going out WAN 2. So we can set up rules based on which interfaces we're going to use, based on the source IP addresses. And as far as my testing goes, here's what I found to be the most solid for my environment. And that's this. I'm training my system to go ahead and use WAN 1 almost all of the time, unless there's a problem with the health check regarding WAN 1, and then go ahead and seamlessly cut over to WAN 2. And that's because WAN 1 is through Cox Communications, and download speed there is very close to a gigabit. And the WAN 2 is using wireless 5G and 4G and LTE. And even though I've got a pretty good antenna, I'm not too close to the tower, and there's some obstructions in the way, so the WAN 2 interface is not quite as fast as WAN 1. So that's how I have my SD-WAN rule set up to use WAN 1 primarily, and if there's a problem with that, go ahead and cut over to WAN 2. Also, if there's a problem with WAN 1 and WAN 2 is active, and even when WAN 1 comes back, I have in my configuration a little timeout that says, hey, you know what, WAN 1 was having a problem, it wasn't as fast as it should have been. I'm going to go ahead and give that a little 2 or 3 minute timeout once it comes back, just to make sure everything's cool and the health checks are all solid before I start forwarding again. So now that we've taken a look at the big picture regarding how I have set up my high availability and fault tolerance for internet service using 2 service providers and a FortiGate with SD-WAN zones, let me give you a first-hand picture of what these elements look like. So here's the FortiGate dashboard. This is the status pane. And I've got the bandwidth on my WAN 1 provider and my bandwidth for WAN 2. It's also showing me here in the SD-WAN widget that I've got 2 interfaces participating in SD-WAN. If we click on that widget to expand it, it shows me I've got WAN interface 1 and WAN interface 2 with current details regarding upload and download on those links. Under network, if we go down to the SD-WAN section here on the left, here's my SD-WAN zone that I created with each of those WAN interfaces being a member of that zone. And they're their respective gateways. I also modified the cost just a little bit to make the cost for the WAN 1 connection a little bit better than the cost for WAN 2. And that way, based on the rules, if they both meet the service level agreement, the health checks, it's going to prefer the interface that has the least cost, which is my WAN 1 connection, which has the higher bandwidth. So on a good day, most of my traffic should be going through WAN 1. It's also showing up here regarding download and upload exactly what's being used. So the green is representing my WAN 1 connection going through Cox cable, and the yellow is representing my WAN 2 interface, which is going through T-Mobile's wireless offering. So that's bandwidth, and if we click on volume, this is the volume of traffic that's gone through, and we can also take a look at the number of sessions at the moment that are currently going through. So most of my sessions at the moment are going through WAN 1. Now, as far as the health checks, that's also right here with the SD-WAN on the left selected. Right here, we can click on Performance SLAs. Effectively, those are the health checks. And here's the health check that I've currently configured. I called it Keith OpenDNS. It's checking on an OpenDNS server as well as a Google server. And with this SLA selected, it's showing us a graph regarding those 2 interfaces. So regarding packet loss, they are both doing great. They've had virtually no packet loss. And if we click on latency, here is the latency column here. And these numbers are being averaged over the last few minutes. And then for jitter, here is the jitter for each of those interfaces. So if we open up this service level agreement, this performance SLA, by double clicking on it, with the prefer passive, it's just going to watch for DNS traffic and measure it. And if it doesn't see DNS traffic, it will then go ahead and do a probe if it needs to do the measurements. So over here on the right, it's currently showing for connection 1 and connection 2, the packet loss, the latency, and the jitter. And again, those numbers are constantly changing every time we're going to refresh on the page. So we came back here and we double clicked on that SLA again. We'll see once again, those numbers are going to be slightly different based on the snapshot in time that it just showed us. And then for the targets for these interfaces, I've set it up for 250 milliseconds for latency. Think of that like delay. If it gets above that, it's going to fall out. It won't be in compliance with the SLA. The jitter is the variable delay, which I've set to 200, and the packet loss threshold is 2%. And so there's a check happening every 1 second, 1,000 milliseconds. And if there's no DNS requests that are made within 1 second, because we're in prefer passive, it'll go ahead and do a probe. But if there's tons of DNS traffic, which there often is, it's just going to measure the requests and responses with those DNS requests to figure out whether or not the interfaces are within their SLA or not. So for the failures before inactive, I set to 3. So effectively, if we fall out of one of these SLAs within 3 of these intervals, which is 1 second each, 3 seconds, it's going to consider that interface as no longer meeting that SLA. And then I have a little timeout of 10. So if there's a problem, it's not going to restore that for at least 10 health checks, which in this case are 1 second apart. Also, you should be aware that regarding things such as packet loss threshold, that's not just a 1 or 2 second thing. The packet loss is actually measured over the last 100 intervals. So it may take a few minutes after an interface fails for it to come back and start functioning. So what we can control are these details regarding the SLA targets and the check interval and the failure before inactive, and then restoring the link after how many checks. And if an interface falls out of the SLA, we are also going to modify our routing to remove that route from the routing table. So check this out here at the command line interface on this firewall. If you use this command, get router info, routing-table all, and press enter, here is our routing table. So we have 2 default routes. That first one is going through my service provider number 1, which is Cox Communications. And the second one is going through the T-Mobile home internet service. So currently I have 2 possible routes. And we can also see that information here by going to the dashboard, clicking on network, and then clicking right here on the routing widget to see the details for the routing table. So once again, here we have our default route going through my provider 1 and a default route going out through provider 2. So if we go back to the SD-WAN and performance SLAs, here we have details regarding the service level agreements as they currently sit. For packet loss, latency, and jitter, we can also see that from the command line interface as well. And that would look something like this: diagnose system SD-WAN health check, press enter. And that's showing us pretty much the same information that we had right here in the GUI regarding packet loss, latency, and jitter for those interfaces. And at the moment, they are both in compliance. So if we brought in a speed test, let's go ahead and do that right now. We'll click on go. So this would be a snapshot in time right now based on my throughput. So currently my computer is going through the FortiGate firewall, and it's pretty good speed, close to a gigabit down through the Gigablast offering through Cox Communications. And for the upload, I'm expecting somewhere over 30 megabits per second. Great, great, great. That's on a good day. And because there's so much bandwidth there, I want to use this primarily for everything unless there's a problem with Cox Communications. So what I did was I created a rule. And this SD-WAN rule says this: if both of these interfaces are compliant, meaning they're both within the SLA, which at the moment, if we hover over these, they both are, it's then going to go ahead and use the one with the lowest cost. So I set up the WAN 1 interface having a slightly lower cost by 1 compared to the T-Mobile. So if they're both good to go, the firewall is going to use the WAN 1 interface for virtually everything. And if there's a problem with throughput on that WAN 1 interface, it's then going to cut over and start using the second WAN link, the WAN 2 going through T-Mobile. And then I specified which health check I'm using, which is the Keith Open DNS, which is doing the DNS tests. And currently here on the right is showing us the SLA details with the WAN 1 and WAN 2 and the latency and jitter for both. And one other confirmation as far as which interface is being used, if we go back to SD-WAN and we go back to sessions, basically here in green, most all the traffic right now is going through WAN 1. Also, because I tested this about 30 minutes ago, I still have a few sessions that are still going through WAN 2. So if we did the speed test again, so I'll go ahead and launch that. I'll let that run in the background. So that's still looking pretty darn good. And if we go to log and report and go to forward traffic, and that'll filter the output. So these represent the speed tests that we did over the past few minutes. And the egress interface, the outbound interface on all of them was WAN 1 based on my rules. So here's what I suggest we do. Let's bring in, this is my local computer, and let's do a ping -t, which is a continuous ping out to 8888. That's a Google server. So that's flying, no problem. And let's also do a speed test. Once again, we'll click on go. So everything's working here. High speed internet access going through my first provider. And then let's do something pretty terrible. And that's right here. I'm going to go ahead and I'm going to do a reset of the modem. So this is asking my cable provider, Cox Communications, to do a reset of the cable modem. So to the firewall, it's just going to look like, whoa, this interface is no longer working. I'm not able to send packets. And the interface, WAN 1, is no longer going to match the SLA. It's no longer going to be used to forward traffic. So all that should be seamless to the internal users. So I'm going to click here on begin reset. And while that happens, let me do another speed test here. So, unable to reset modem. All right, so let me try again. I had to rearrange my screen to remove any sensitive data. So I'm going to go ahead and reset device. And the survey says, let's reset your modem. I'll go ahead and click on begin reset. And let's do another speed test while that's cooking. So they're doing the reset right now. And it may take a moment or two for that to kick in. So we may get part of a speed test done before the cutover. So let's see here. Okay, so based on the download speed, I can see right here, like 130 megabits per second. That is actually going through T-Mobile. Again, transparent in the background with that cutover. So look at that. There's a couple pings that timed out. But for the average user who's streaming something or working online, they probably wouldn't notice that that even happened. Effectively, it'd feel like it's transparent to the internal user. So I'm going to do a Control-C to stop the ping. And let's go back to the CLI. And if we hit the up arrow key a couple times, here's the routing table. So it removed the route that was going through WAN Internet Provider 1, which was through Cox Communications, because the interface no longer passed the SLA test, the health check. So now it's only using the path going through T-Mobile, through WAN 2. So once the reset is totally done on the cable modem, which may take a few minutes, and then once the parameters for the health check falls within the SLA, it'll put that route back in the routing table, and our SD-WAN rules will then tell the firewall, go ahead and start using that WAN 1 link again. So back at SD-WAN, if we click on SD-WAN zones, right now, if we go to sessions, most of our sessions are going through WAN 2, and we may have a few lingering ones that aren't currently being active because WAN 1 is no longer working. So if we click on bandwidth, and we take a look at what's currently being used for download and upload, it's mostly WAN 2, because that's the interface that's currently active. And if we go back to the dashboard, and we click on network, and we go to status, and let's run that speed test again. We'll click on go to run the speed test. So my speed test still thinks I'm using Cox Internet Services because that's where I started off, but I'm not. I'm currently using on the back end. We're now using T-Mobile at the moment. So there's the inbound and the outbound regarding WAN 2 at the moment. We can also go back to the logs, and under log and report, we can go to forward traffic. I still have a filter in place just looking at speed test. And if we scroll down, check it out. We were using WAN 1, then it cut over to WAN 2. Looked like we had one more little try there for WAN 1. And then it was all WAN 2 all the way forward. And if we change the filter and we look at pings, because we have the continuous ping running, so I'll go over here and let me just go grab ping. I'll right click on it and specify we want that as a filter for what we want to look at. So if we scroll down, here we have WAN 1, WAN 1, WAN 1 for days. And then once it cut over to T-Mobile, which is WAN 2, and that's what we currently have. So once that interface comes back up and meets the SLA, we should have 2 routes. Oh, it's back. So now we have, yet again, a second next hop regarding our default route. And this one is using our WAN 1 interface and the cable provider. And then once this interface, WAN 1, meets that SLA, the SD-WAN rules will say go ahead and start using that WAN 1 interface again. So here back in the GUI, if we go back down to SD-WAN, and then performance SLAs, and we click on this SLA, and we go to packet loss, it looks like we are back in business. And so if we did a speed test again here, by clicking on go, this should now be using the WAN 1 interface with much higher throughput, sure enough. So a little over 900 megabits per second down. And once again, I would expect approximately 30 or 40 megabits up. And that, my friend, is an example of using high-speed internet connectivity with fault tolerance by leveraging 2 service providers and some gear that can monitor those links and then choose the best paths based on what's available. So thanks for lending me your eyes and ears for a few moments as I shared with you my implementation of fault tolerance and high availability regarding internet connectivity. And I'll see you, my friend, in a future video or live event soon.